Normalization is a scaling technique in machine learning applied during data preparation to change the values of numeric columns in the dataset to use a common scale. It is not necessary for all datasets in a model. It is required only when features of machine learning models have different ranges. Standardization scaling is also known as z-score normalization, in which values are centered around the mean with a unit standard deviation, which means the attribute becomes zero and the resultant distribution has a unit standard deviation. Mathematically, we can calculate the standardization by subtracting the feature value from the mean and dividing it by standard deviation. Which is suitable for our machine learning model, normalization or standardization? This is probably a big confusion among all data scientists as well as machine learning engineers. Although both terms have the almost same meaning, choice of using normalization or standardization will depend on your problem and the algorithm you are using in models. 1. Normalization is a transformation technique that helps to improve the performance as well as the accuracy of your model better. Normalization of a machine learning model is useful when you don't know feature distribution exactly. In other words, the feature distribution of data does not follow a Gaussian, bell curve, distribution. Normalization must have an abounding range, so if you have outliers in data, they will be affected by normalization. Further, it is also useful for data having variable scaling techniques such as KNN, artificial neural networks. Hence, you can't use assumptions for the distribution of data. 2. Standardization in the machine learning model is useful when you are exactly aware of the feature distribution of data or, in other words, your data follows a Gaussian distribution. However, this does not have to be necessarily true. Unlike normalization, standardization does not necessarily have a bounding range, so if you have outliers in your data, they will not be affected by standardization. Further, it is also useful when data has variable dimensions and techniques such as linear regression, logistic regression, and linear discriminant analysis.